Hello and welcome to Probability Theory brought to you by Expert Education Center. My name is Peter Ohwe. Probability may be defined as the chance of an event taking place. It can also be the chance that the event will not happen. That is, the likelihood that a particular event will come to pass or otherwise. For instance, if there are 10 balls in a bag such that the balls are of the same size, okay, and 7 of them are blue and the others red, we can go ahead to determine the probability of picking either a blue ball or a red ball because those are the only two colors available in the bag. Therefore, the probability of selecting a blue ball is the chance that a blue ball will be picked rather than a red ball. And in this case, there are more blue balls because 7 balls are blue, the others are obviously red. Therefore, the probability of picking a blue ball is 7 out of 10. And that gives us 0.7. 70% chance of picking a blue ball. On the other hand, if we were to find the probability of choosing a red ball, that would be equal to the number of red balls divided by the total number of balls in the bag. And we end up with a 30% chance of picking a red ball. That is how probability works. You look at the total number of events and then compare it with the total number of possibilities. Therefore, probability can be represented as a simple ratio, which in this case will be the number of times an event occurs divided by the total number of possible occurrences. For instance, if X is an event, then the probability that X will happen, written as P of X, will be given as the number of times X occurs divided by the total number of possible occurrences, where S is the sample space. Probability is a very useful tool when it comes to decision making and problem solving. We would like to take some examples to see how probability helps us to take the right decisions. As an example, an unbiased coin is tossed once. We are expected to determine the probability that the outcome is a head. Note that a coin has 2 sides, and that gives us the total number of possible options, which in this case is the sample space. This is an example of a coin. Like we said, a coin has 2 sides. One side is known as the head, and the other side, the tail. The number of heads is 1, clearly seen in this example. The sample space is 2. Therefore, the probability of obtaining a head when a coin is tossed once is the number of heads divided by the number in the sample space. And we end up with 50% chance. Therefore, the probability that in a single toss of a coin, the head shows up will be 1/2. In the same way, the probability that when a coin is tossed once, a tail shows up is equally 1/2. Moving forward, suppose 2 coins are tossed at the same time. Now, we'll have more possibilities. This is equivalent to saying you toss a coin twice. In experimental probability, tossing a coin twice produces the same sample space as tossing two coins at the same time. Let's take a look at the sample space of a coin that is tossed twice or two coins that are tossed simultaneously. This is the sample space. There are four possibilities. The first possibility is that the first coin comes up with a head and the next one comes up with a head. The second possibility that we have is a situation whereby the first coin is a head and the second coin comes up with a tail. Don't forget that we already told us that tossing a coin twice is the same thing as taking two coins and tossing them at the same time. The third possibility is that one coin comes up with a tail and the other has a head. Or the fourth possibility, which is both coins turn up the head. The probability of obtaining two heads is the number of times that we are going to have an outcome, an event that produces two heads, divided by the total number of possible occurrences. So, if we have only one space for head, and the sample space is made up of four possibilities, the probability of having head and then head will be 1/4. And that will be 25% chance that when you toss two coins simultaneously or you toss a coin twice, you have a 25% chance that both coins will produce heads, or the same coin will come up with a head twice. On the other hand, if our focus is what is the probability of obtaining two tails, that is, the first coin comes up with a tail and then the next one is also a tail, that probability will be 1/4. Why? There's only one number 4 option that gives us tail and tail, and the sample space is actually 4. If we now consider the probability of obtaining one tail, obtaining one tail out of two coins or tossing a coin twice implies that you have one tail and then one head. The order is not relevant in this particular question. The question just says obtaining one tail. The two options that gives us one tail are number 2 and number 3. However, if the question were to be what is the probability of having a head then a tail, our answer will be 25% chance, a head then a tail. But this question comes up with one tail. One tail implies head tail or tail then head. Therefore, we have a 50% chance, which is 1/2. What about the probability of obtaining at least one head? It is important to define this problem. At least one head implies one head or two heads. Since we have two coins tossed, or like we've continued to reiterate, either a coin is tossed twice or two coins are tossed simultaneously. At least one head means one head, which the possibility 2 and possibility 3 clearly shows, or two heads, which is the first event. Our solution will look like this. The three possibilities that will give you at least one head, that is the three events, are event 1, head first, then tail, event 2, tail, then head, and the third event, which is head, then head. Therefore, we have 3 events that are out of 4. The probability of at least obtaining one head would then be 3/4. And this is 75% chance. So you are more likely going to have at least one head than having exactly one head. Our second problem comes from rolling dice and playing, very interesting games, such as Ludo, such as dominoes, and so on. In this particular question, a fair die is rolled once. A fair die is a die that is well, structured such that there is no bias towards any of the faces. A die has 6 sides. It's a cube. Therefore, the sample space for a die will be 6. Each of these faces have distinct numbers. The first face produces 1, and as you continue, like you can see in this particular diagram, a fair die has 6 faces. The sample space for a fair die is 6. Suppose we are asked to find the probability that the number 4 appears. Since a fair die has 6 faces, and only one of the 6 faces shows up the number 4, then the probability that 4 will appear in a single die throw will be the number of times 4 will come up in that throw over the number of possible faces that the die has. And our answer will not be 4/6, which is a common error when it comes to this type of question. Our answer will actually be 1/6, because only one face comes up 4, whereas the sample space is 6. What then is the probability that the number that appears is an odd number? An odd number is a number that is not divisible by 2. Every number divisible by 2 is then an even number. Let's quickly confirm. The odd numbers in a single die throw will be 1, 3, and 5. The odd numbers are 1, 3, and 5, and the sample space is made up of 6 numbers. Therefore, the probability of obtaining an odd number when you roll a fair die once will be 3/6, which is 1/2. What about having an odd number? We've said that if a number is not odd, then it is even. However, note that we are talking about natural numbers here. We're talking about whole numbers. So the probability that our number is even will be 1/2. That is either 2, 4, or 6. The probability of producing a prime number. A prime number is a number that is divisible by itself and then 1. 1 is not a prime number. Again, I say 1 is not a prime number because 1 has just one factor, and that factor is 1. For a number to be prime, it must have 2 factors. The factors are itself and then 1. The prime numbers in this sample space are 2 divisible by itself and 1, 3 divisible by itself and 1, 5 divisible by itself and 1. 4 is not a prime number because 4 has 3 factors: itself, 4, 2, and then 1. The probability of obtaining a prime number, therefore, will be 3/6. In that same experiment, what is the probability that the number that appears is a factor of 24? At most 4. A multiple of 3. Finally, greater than or equal to. Please go ahead, pause the video, try out these questions, and then resume the lecture. Welcome back. In a single toss of a die, the sample space is shown clearly as 1, 2, 3, 4, 5, 6. The factors of 24 are 1, 2, 3, 4, and 6. These are not the only factors of 24. 8 is a factor of 24, 12 is a factor of 24, and 24 is a factor of itself. Having said that, only 1, 2, 3, 4, and 6 can be found on the faces of a die. The only number that is not here is 5, because 5 is not a factor of 24. The probability that if a die is rolled once, the result that turns up is a factor of 24 will be 5/6. The probability that our result will be at most 4. At most 4 means the number 4 or less. The number 4 or less than 4. And that will be 1, 2, 3, and 4. Therefore, the probability that our result or the number that shows up when a feather is rolled once is 2/3. A multiple of 3. Multiples of 3 are numbers that are divisible by 3. Greater than or equal to 2 refers to 2 and numbers greater than 2. You can go ahead, solve these 2 questions, send your answers to prohue10@yahoo.com. As we proceed to another experiment. Suppose 2 fair coins are tossed together. This is the same thing as suppose 2 dice are tossed together. This is the same as rolling a die twice. If you roll a dice twice, or you roll 2 dice simultaneously, the sample space is the same. So we are going to generate the sample space for rolling or tossing or spinning 2 unbiased dice. This is the sample space. The horizontal identities are for one of the 2 dice, while the vertical identities are for the other die. So we have chosen to call one of the dice A and the other B. So the possibilities for B will be 1, 2, 3, 4, 5, and 6, represented by these 6 columns. For the other one, the values also will be 1, 2, 3, 4, 5, 6. So for A, there are 6 possible events. The sample space is 6. Event 1, event 2, event 3, event 4, event 5, and event 6. For B, the possible events are also 1 to 6. Taking these 2 events together, these dice together, which now becomes a single event when you toss or roll the dice simultaneously, we have in our first row that A gives you 1 while the other one gives you 1, the sum will be 2. In this particular question, we are interested in the sum, as you will see as we continue with this solution. In the second column, or third column as you like, die A gives us 1 while B gives us 2. Then in the third column, we have 1 and 3, 1 and 4, 1 and 5, and 1 and 7. The results written in red is the sum of the 2 numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. The examiner is free to ask you questions on this, but if you can capture this sample space, then you are on your way to answering whatever questions that comes up in this particular experiment. Let's take a look at the second row. Notice that the number 2 is consistent because we are considering the second row. Therefore, we have 2 and 1, 2 and 2, up to 2 and 6. Once again, the sum of the two numbers is represented by the red numbers. In the third row, we have the same thing happening. Number 3 is consistent. And like we said, the dark numbers are for die A, the blue numbers are for the die B, and the sum of the two numbers is represented by the color red. So the fourth column gives us this arrangement. The fifth column, one thing I want us to notice is if you consider the columns, you will see that the numbers are the same. If you consider the rows, you will see that the numbers are equally the same. What do I mean by this? If you consider the columns, the blue values are the same. And if you consider the rows, the black values are the same. This is the last row. If you are able to count, you can pause the video here and then check the sample space. Yes, the sample space is 36. To find the probability that the sum of the two numbers is a single digit, B, a prime number, C, at least 8. Note that we are considering the sum. So our focus will be on the red numbers. The probability that the sum of the two numbers is a single digit is the number of times we have a sum that is unit. A number that is unit, not a double digit. Just a single number, not tens. Divided by the sample space. The number of single digits is actually 30. What we have done is we have removed those numbers that have double digits. The 10, the 11s, and the 12s. We've taken them off. Therefore, the probability that if two dice are rolled simultaneously, a single digit comes up, is the number of times we are going to produce single digits, which in this case is 30, divided by the total number of possibilities, which is 36. That is the sample space. Therefore, our result will be 5 divided by 6, which is 5 over 6. Find the probability that the sum of the two numbers is a prime number. A prime number is a number that is divisible by itself and divisible by 1 as the only factors. Therefore, 2, 3, 5, 7, and 11 will be our prime numbers. Something to say here. 2 is the only prime number that is even. All other prime numbers are odd numbers. If you are asked to list the prime numbers, you pick 2. Incidentally, it's the first prime number. And then you continue to add other prime numbers, which obviously will be odd. But be careful with this problem, because the prime numbers are 2, 3, 5, 7, 9 is not a prime number. 9 is not a prime number because it has 3 factors, 9, 3, and 1. The other prime number in the list is 11. Therefore, we have 15 prime numbers in this sample space. The probability of picking a prime number is 15 over 36. And our answer will be 5 over 12. Go ahead and find the probability that the sum of the two numbers is at least 8. D, a factor of 24. E, a perfect square. A perfect square is a number that has a square root that is a whole number. So, a perfect square is a whole number whose square root is a whole number. Solve these problems. Send your answers to prohue10@yahoo.com. Drop your comments and don't forget to hit the subscribe button. Thank you very much and God bless you.